All right, so far with slope fields, you have drawn slope fields that go with the differential equation. You've matched the slope field with its solution. This time we're going to actually match a given slope field with the differential equation. So at the end of this lesson, you will be able to match a slope field with its differential equation. All right, let's do some examples. This one says to match the slope fields with their differential equation. So if you were actually going to draw the slope fields, which one of them will they be? And these ones are a little bit hard to read, but we're going to try our best to do so. One thing that I am going to point out on this one, these slope fields are super duper teeny, which is going to make this a little bit more difficult, but I believe the slope fields were made every half, so just kind of keep that in mind as we're going along. Alrighty, what I like to do, kind of a technique that I like to do, is figure out where my slopes would equal 0, because that's going to help us decide some things, and where might it be undefined, because that might help too. Okay, so if I look at this first one, again, dy dx just stands for the slopes. So if I'm looking for where is the slope of these slope fields going to be 0, that would be when y equals 4. Okay, and the next one, again, dy dx are my slopes. Where would my slopes equal 0 on this one? And that would be when x equals 4. Okay, on my next one, again, dy dx is just a slope. I'd be looking for where would my slopes equal 0, where there's two places this time, at y equals 0 and y equals 4. And then the last one, if I'm looking for where would the slopes equal 0, and that would just be when y equals 0. So now I'm going to try to use that information to help me out. So if I look at this one right here, I notice that it looks like 1, 2, 3, 4. It looks like about y equals 4 is where I see slope fields of 0. On this one, I notice my lines are kind of going the other way. At x equals, it looks like at x equals 4, I have lines that have slopes of 0. On C, I think I see it in two places. First of all, I see slopes of 0 at 4, and I believe it's kind of hard to see, but I also see slopes of 0 at 0. And then my last one, I really only think it's kind of hard to see this again, but it looks like they're getting really small over towards y equals 0. So I believe that would be at y equals 0. So kind of you can tell I matched them up quite nicely here. Here at y equals 4, they have slopes of 0. So we have a match. Here at x equals 4, got a match. This one was at 0 and 4, we got a match. And this one, when y equals 0, we had a match. Now, one thing that I do want to point out, sometimes we might have like all of these equations turned out to be the same thing, like maybe this one, like if I had dy dx equals y squared, and then I had dy dx equals y cubed, those would both have slopes of 0 at y equals 0. So then I'd have to start testing some points. One thing that I would test on this one, y squared, no matter what I plug in and square it for my y values, my slope is always going to be positive, so all of my lines should have positive slopes. And now on this one, when I plugged in any negative numbers for y, I'd get negative slopes for my y's. So that would be one thing that I could distinguish between the two. So if the original kind of hint that I used didn't work, then we can actually start testing individual points to see which ones might match up. But hopefully now you can match slope fields with their differential equations.